Astronomers agree that the universe is approximately 14 billion years old, based on observations from an observatory high above Chile's Atacama Desert. Astronomers have taken a new view of the oldest light in the universe. Their observations, inclusive of some cosmic geometry, suggest that the universe is 13.77 billion years old. They have also taken into consideration 40 million years. Based on research that have been conducted, the new estimate was done using data gathered at the National Science Foundation's Atacama Cosmology Telescope. This data matches the one that was provided by the Standard Model of the Universe, as well as measurements of the same light made by the European Space Agency's Planck satellite, which measured remnants of the Big Bang from 2009 to 2013. Based on these data, it seems like the research team is measuring the movements of galaxies calculated, and that the universe is hundreds of millions of years younger than the Planck team predicted. That discrepancy suggested a new model for the universe might be required, and sparked concerns that one of the sets of measurements might be incorrect. At this point, they need to come up with an answer where Planck and ACT agree. It speaks to the fact that these difficult measurements are reliable. Astronomers have been taking a look at primordial black holes in the search for dark matter from the multiverse. Based on information coming from the Kavli Institute for the Physics and Mathematics of the Universe, there is a home to many interdisciplinary projects which benefit from the synergy of a wide range of expertise available at this institute. One such project is the study of black holes, which could have formed in the early universe before stars and galaxies were born. These primordial black holes could account for all or part of dark matter. It could also be responsible for some of the observed gravitational waves, signals, and seed supermassive black holes found in the center of our galaxy and other galaxies. They could also play a critical role in the synthesis of heavy elements when they collide with neutron stars and destroy them. Destruction of neutron stars normally leads to the release of neutron-rich elements and materials. Specifically, there is also an exciting possibility that the mysterious dark matter, which accounts for most of the matter in the universe, is composed of primordial black holes. Since black holes were known about to exist in nature, they make a very appealing candidate for dark matter. Based on recent progress in fundamental theory, astrophysics, and astronomical observations in search of primordial black holes, it has been very important for international teams of researchers, particle physicists, cosmologists, and astronomers, including Kavli IPMU members, to work on this theory. Their intention is to learn more about primordial black holes. Based on what the research team has observed so far, whilst looking at the early universe for clues, it seems the early universe was so dense that any positive density fluctuation of more than 50% would create a black hole. However, cosmological perturbations that seeded galaxies are known to be much smaller. Nevertheless, a number of processes in the early universe could have created the right conditions for black holes to form. One exciting possibility is that primordial black holes could form from the baby universes created during inflation, a period of rapid expansion that is believed to be responsible for seeding the structures we observe today, such as galaxies and clusters of galaxies. During the inflation period, baby universes can branch off of our universe. A small baby or daughter universe could and would eventually collapse, but the large amount of energy released in the small volume causes a black hole to form from it. Consideration is, what if a larger baby universe was formed? If it is that a larger baby universe than some critical size were to be formed, Einstein's theory of gravity allows the baby universe to exist in a state that appears different to an observer on the inside and on the outside. An internal observer sees it as an expanding universe, while an outside observer would view it as a black hole. In either case, the big and the small baby universes are seen by us as primordial black holes, which conceal the underlying structure of multiple universes behind their event horizons. The event horizon is a boundary below which everything, even light, is trapped and cannot escape the black hole. These researchers believe that the black holes would have come from a multiverse scenario. And of course, they would have utilized the Hyper Supreme Cam of the 8.2 mm Subaru telescope, a gigantic digital camera which is used in the management of Kavli IPMU, and this has played a critical role in this research. Like, comment, share, and subscribe. Let me know if you agree with the astronomers that the universe is approximately 14 billion years old. And of course, what of the primordial black holes that persons, including astronomers, scientists, and researchers, are looking at to determine what composes dark matter in our universe. Thanks for watching. Goodbye.